All right, it's 11 o'clock. We'll give one more minute, let people join in. Just one more minute. Okay, so we are officially 1 minute past the hour. Welcome. We appreciate your participation. My name is Meeta Pandey. I am Vice President, Partnership and Strategy at EazyML. And on behalf of EazyML team, I welcome everybody. Appreciate your participation. The topic of today's webinar is Augmented Intelligence from Data to Decision in Minutes. So let's look at the agenda. Okay. I'll go through the introductions of the speakers. We'll discuss the challenges that the enterprise face today. We'll discuss what is EazyML, what is explainable AI and augmented intelligence, and how EazyML is addressing the challenges that enterprises face today. We will demo a financial industry use case, and we'll also demo a healthcare use case. Then we'll discuss the key takeaways. And at any time, if you have any questions, please feel free to enter in the chat, and we will answer them towards the end of the webinar. So to introduce the speakers, we have Deepak, who is the CEO of EazyML. And the second speaker is Pranay, who is President of Products at EazyML, and that's me. So I want to start off by defining what is transparency in EazyML. So ML transparency explains the reasons behind its predictions, recommendations, and insights. And it is a must for man-machine collaboration. And it's also demanded by regulatory compliance. Unfortunately, it's been sacrificed by increasingly complex and opaque models. For example, deep learning framework. Many vendors, including Microsoft and Google, they're working very hard to make ML transparent. And EazyML has worked very hard at it for quite some time to make ML transparent. And even more importantly, actionable. Actionable is the key word here. So we believe EazyML is ahead of the curve. So what really constitutes transparency? People usually think that transparency and explainable AI are interchangeable, they are synonymous. But at EazyML, we think it's a very narrow view. We believe that transparency has 3 dimensions. So let's see what are these 3 dimensions. Augmented intelligence, that's one dimension where you mine insights from your data automatically. Explainable AI is the second dimension where you make predictions and you explain the predictions, the reasons behind the predictions. And the third dimension is traceability, where you can go back and trace your step-by-step how ML is processing your data. How did you build your model? And you can troubleshoot and iteratively improve. So those are the 3 pillars or 3 dimensions that are important and that make a transparent machine learning platform. So since today we are talking about augmented intelligence, let's define what augmented intelligence is. So very simply put, augmented intelligence mines insights from your data automatically. Analysts mine data today manually using IT and BI tools, and it's a very tedious and long process. And sometimes they can miss out key insights because of their inherent biases. Augmented intelligence, it objectively mines insights. It doesn't have any preconceived notions or biases. So it helps make the analysts more productive because they can really take these raw insights from augmented intelligence, refine it, generalize it, package it, and with graphs and rich reports, and construct a story. So augmented intelligence, auto insights, simple rules. Insights are very easy to comprehend. They are just simple rules of predictors. And most importantly, these insights are accompanied by confidence scores. How confident is the machine about the accuracy of these insights? You can determine which insights you want to act on and which insights you want to ignore. So that's what augmented intelligence is. Gartner estimates that this year alone, augmented intelligence will add 2.9 trillion worth of business value to enterprises globally. So I think at this point, I will turn it over to my colleague Pranay, who will give an overview and start with the demo. Pranay, it's all yours. Take it away.
Meeta. Greetings, everyone. Good morning, good evening, good afternoon, depending on which time zone you are in. I'm going to talk about a specific use case today that Meeta mentioned earlier. This is going to be from the financial services industry. Now, it's about commercial credit underwriting for thin file merchants, and within that, it's specifically two sub-use cases. The first one is the faster onboarding of thin file merchants, and the second one is about better decision making. So I'm going to share with you a data set, and I'm going to stop my video so that it doesn't interfere with the screen sharing or audio. So just give me a moment. All right. So this is the data set from the world of commercial credit underwriting for small to medium businesses. Now, what you are looking at in here is the first column talks about all those merchants who should have been approved or declined at the time of lending. Now, when we say thin file merchants, what does it mean? Well, these are the merchants for which there is not a lot of information available to the financial institutions, the banks or the lenders. So where do you go for information on these merchants? Well, an obvious data source today is internet. Internet is a treasure trove of a lot of information on all of us, as we all know today. And so is the case with these thin file merchants. Now, the information may not be available from banking or payment point of view, but there is a lot of information available if they happen to have online presence, or even if they don't have online presence, there may be information available on social media, on blogs and media posts about these thin file merchants. Now, this information is a leading indicator, the one on the internet. Traditionally, as we all know, the banks have been using information like the bank statements, the revenue statements, the assets, and the information from credit bureaus. But that information, although has been in use for quite some time, is a lagging indicator. And when I say lagging indicator, what it means is if something were to happen to these businesses today, it'll take a couple months or maybe more for the impact to be reflected in your finances. Now, imagine if you were to combine these traditional indicators with the leading indicators from the internet. Right? There is significant potential for boosting your decision-making power. Right? Now, but the question is, how do you make these leading indicators, the one from the internet, actionable? Unless you make it actionable, those information elements are of no value to the enterprises. So here in this data set that you're looking at, every single record is about a particular merchant, who has reached out to this financial institution for seeking funds in the past. Now, the first column says, what should have been the loan decision at the point of lending, at the point of application due diligence? The rest of the columns in here are the information elements from the internet. You can see there's information about footprint across the board on various platforms, including social media such as Facebook, Twitter, or LinkedIn, Instagram. There is information about how is this merchant perceived in the eyes of its own customers, like sentiments or reviews in the past quarter, most recent quarter, or the quarter before that. Information about the website. If they happen to have an online presence, they have a website, then you have very key information elements like how rich is the website, how, in terms of content, how popular is it among its visitors? Does it have enough visitors? Does it have a good page rank? Unless you have a good page rank, good luck finding a business from your customers, because they are unlikely to find you in the first few pages of Google search or any internet search engine. And so on. All this information is also referred to as the alternate data. The banks of late, or financial institutions in general of late, have acknowledged the value and the importance of the alternate data and complementing it with the traditional data sets, like the information from credit bureaus and others. Now, again, back to the question is, how do you make all these information elements actionable? And what does actionable mean? Again, in the context of two use cases that I was talking about, the use case number one is about faster onboarding of thin file merchants. These are the merchants about which there is not a lot of information available from banking or payment point of view with the institution. And the second is about better decision making. The banks or the financial institutions, they have the underwriting guidelines and processes in place and has been working reasonably for them. But if you were to combine this, there is a lot more improvement in terms of decision making. Now, I said, what does it mean to have these information elements actionable? Well, what it means is, given so many information elements, which one of these are important? Which one of these play an important role in decision making, and how important role? And is there an interplay between or among these information elements? There are so many of them. So let's say if you had a data set like this based on the past performance of your borrowers in the portfolio, where you know that these decisions should have been declined instead of approved, or vice versa, what kind of rules would you think be applicable? So let's say if I were to do this exercise with you here manually. So I'm looking at all these declines and approved. Is there a common pattern? That's what I'm looking for. If as a subject matter expert, if I want to establish a rule for guidelines or guidelines for underwriting process, I need to have those patterns identified. So let's say I have this whole group of declines in here or in here. Is there a pattern? So I would start off with this. I'm looking at these group of declines in here. A whole bunch of them, they have zero footprint on the internet. Maybe that's why they should have been declined in the first place. Is that the case? Well, for most of them, it looks like, but wait a minute. I come across a rule here, a rule violation, an exception here. This is a non-zero footprint, and still it should have been declined. Why is that so? Then I start looking at other information elements across the board. Well, for this case, I do see that the sentiment is strongly negative. So maybe my rule should be enhance to say that if it's a non-zero footprint and the sentiment score right here is a strongly negative, maybe that's when it should have been declined. So maybe I have a rule now. Does that rule hold across the board? If I go across the board again, I come across these couple cases in here where the non-zero footprint and strongly negative sentiments, then this case should have been approved. It's violation, exception to my rule. Is that just a one-off case? Maybe, it's just an exception. Let's see. Well, not really. I see a whole bunch of other scenarios in here which were approved. So my rule for decline is not really holding its ground. This is a very exhaustive exercise if I were to scan through this data set or apply even BI tools to come up with these rules. And that is where augmented intelligence comes into play to my rescue. I'll rely on that. So like Meeta said, augmented intelligence, it's going to auto-derive the rules. And rules in form of, in form that humans can easily understand. So I'm going to take this data set and go out to EazyML, the augmented intelligence functionality right in there. I'm going to log into the portal. I'm logged in here. This is my landing page. Now, EazyML is a Q&A driven user interface. It has no expectations from user in terms of any data science experience or machine learning experience or programming experience. No preconceived expectations on user's behalf. It's going to walk you through the process by a simple question and answer sequence. So I'm going to upload that data set I talked about. I'm going to upload it from my local file system, although I have a choice to upload it from anywhere in the cloud. For the purpose of demonstration in here, I'm going to upload it right from here. Okay. I've been playing with this data set. That's why it says duplicate, but that's okay. I'm going to just override it. Here is my training data with all those information elements and the loan decision label. Okay. I'm going to go through the process. I don't have a loan identifier in here. I'm going to skip that. I'm going to skip that. Here is a screen which shows that the platform has auto-determined the data types for information elements in the data set. If I agree with it, most of the time, the platform is making auto-determinations, making recommendations. More often than not, they conform to your common sense. If they don't, then all powers to you. You can override. There is an overriding capability offered to the user. But I'm going to go just proceed with this simple navigation sequence in terms of question and answer. Outliers removal. The platform recommends I should remove the outliers, and I'll go with that. By the way, any point of time, if you have a question about what is going on in these screens, you can click on this question mark on the top right. And there is a help. There is a help talking about what this particular step in the sequence is about, outlier removals. What are outliers? You don't have to have a prior background. The help will offer you enough overview to get an understanding of what's going on. And if you were interested in the details, so there is, you can always click on more help and it goes into further technical details. In fact, identifying or telling you what algorithm is being used behind the scenes. Okay, so I'm going to proceed with outlier removal. Fortunately, there are none present in this data set. If there were any, it would have removed it for you. Okay. I'm almost done with pre-processing the data before I call the augmented intelligence functions. There is one last step in here, which is important, is to identify the outcome variable. What is it that you are interested in? It's loan decisions. That's my outcome. I'm interested in that. Loan decision is the outcome. EazyML platform will build the models. First step completed. I'm right here at the model building. phase. Now in here, I have multiple choices. You can build traditional predictive models and explore the world of explainable AI. You can build time series model and explore forecasting, or you can build the augmented intelligence model. Here I'm interested in, is there a way I can solve those two use cases, faster onboarding of merchants and better decision by using an auto-derived rule set. So I'm going to go with the augmented intelligence. It's a classification problem. Why so? Because the outcome variable is categorical. The loan decision outcome is approve or decline. There are only two categories. It's a binary classification problem in this case, but you may have a data set where you could have more than two categories, 5 categories or 7 categories. So I'm going to go with that. Again, the EazyML recommendations and run the augmented intelligence function. Now, here are the results. What do the results tell me? Well, the very first column is what is the outcome for which you are seeking the rule set. That's the first column. The second column is where I have the auto-derived rules. Now you can see that there are so many of them, auto-derived. I was struggling with just one. And even in that one, my confidence was pretty poor. But here I have a whole bunch of choices. The platform has scanned through the entire data set, run all sorts of analytical models, the augmented analytical models, and automatically derive these rules. Voila. Now, what does a rule look like here? Or what does an insight look like in terms of set of rules? So if I were to, let's say, double click on this, it says, or maybe I should look at the rules where underwriters are more interested. It's somehow it's the decline that is of more interest than the approve. So if I were to just narrow my universe of outcomes to decline, here are my rules. Okay, and I will go back to the approve as well. But decline, the rule says, or the insight says, all those candidates which you believe should have been declined in first place based on their historical performance after they were brought to your borrower portfolio, all those who should have been declined in first place share these common characteristics. Remember, I said about actionable intelligence. And what does actionable mean? Among all those variables, which one of those were important in terms of their role in decision making? So now I know these are the ones. The content score, their online presence. If you claim to be an online retail business and don't have a strong online presence, good luck finding business. Page rank plays an important role. Again, if you are an online merchant, you better have a good page rank so that your customers can find you on the first couple of pages of Google search, and so on and so forth. The important variables. And how important? Well, the rank order tells you that. In what way is important? It not only tells you it's important, it gives you a very specific threshold. It says content score was less than about 2.5 on a scale of 5 stars. Our rank score was less than about 3.75 on, again, scale of 5 stars. So it tells you a specific threshold. Again, this is objective mining of rules from the data set. Now, when you see these specific threshold, these rules now become prescriptive. So imagine if there was an applicant, a candidate reaching out to you for seeking funds, and you are declining, you could be very specific in your reasons why you're declining. Now, here I'm talking about just the alternate data from the internet. But this is very much true if you were to combine this data with your traditional indicators like credit score or assets. You might see rules like, your credit score less than 650 sorry, we can't. Credit score less than 650, your page rank poor, your content score is poor, and your assets are below certain threshold. Sorry, we can't extend funds to you. Now, these thresholds are making it prescriptive too. You can, rather than bluntly telling your customers, you can tell him or her specifically, you know what, why don't you hire a web development firm and improve on improving your web presence? Or why don't you hire an SEO firm and improve your page rank? And also make sure you do your credit card payments on time so that your credit score improves. Don't go shopping around for too many loans. Otherwise, your credit score may take a hit. And come back to us after a few months. Maybe we can do something for you. So see how important or rather how rich the customer experience becomes because you are giving a specific feedback. Now, I'm so glad that the augmented intelligence function was able to mine these rules. But what is the confidence? When I was going through manual derivation of rules, that process, I realized my rules were failing, within, one step after another. I wasn't able to find a coherent set of rules which would, conclusively give me an indication why a candidate should be declined. So what is to say is the confidence in these rules. Now, when we talk about the accuracy or correctness of models, we know in the very well we know in the data science world or academics that when you talk about accuracy or correctness of models, there are well-established measures like kappa, precision, F-score, and so on and so forth. But what's there to measure the accuracy of the reasons itself, the correctness of the reasons itself? That is where you have a guide in here in this scores column. Again, like I said, it's objective mining. So every one of these insights are associated with a score. So not only do these conditions, along with their thresholds, make these insights actionable, the other dimension of actionable is the scores, confidence score. This is something which we had to invent. It's not right. It's not out there. No. There is no measure to say what is the goodness of reasons, the insights. Now, these confidence scores allow you to have your own acceptable threshold. You may say that, all those insights which are in the 80s and above, only those I'm going to pay attention to. The rest of them, I'm not going to pay attention to. Or you may say all those above 75 are what I'm going to pay attention to. Or you may have, a stratified, strategy where you may say that all those rules which are 90 and above, maybe those are eligible for good rates, on good interest rates for loan. Those in the 80s to 90s, maybe the next tier of, rates that you're offering for loan, and so on and so forth. So it gives you power to, stitch together your process around the confidence score. Now, remember, I was talking about the two use cases. One was about better decisioning. Now, you can see that when you complement alternate data, your decisioning improves. But what about the thin file merchants? Now, let's thin file merchants about which there is not much information with the institution from payment or banking point of view. They wonder, how do we onboard those faster? Now, you may have a strategy saying that all those merchants which conform to these rules, although I do not have information from the traditional world, or a lot of information from the traditional world, I do have information about these candidates from the internet world, the alternate world. I'm going to rely on that. And I'm going to design my processes around these insights to onboard those candidates faster. Rather than looking for information all over the place for those candidates, I have this information mined automatically from the internet and then applied to augmented intelligence function. Now I have these rules that I can apply and onboard those candidates faster. Again, you can use confidence score to stitch together your processes. So both of those use cases become so much feasible, and notice, how productive an organization becomes if you have the augmented intelligence. Now you may say that, the augmented intelligence, all good, but I want to have my own flavors and tweaks. I want to have that power to be able to tweak the behavior of this function. Well, if that's the case, you have become familiar with the platform and you are becoming an advanced user, and you want to tweak the behavior. All powers to you. You go to the settings, and in here, you'll find settings for all kinds of technical parameters which modulate the behavior of functions like explainable AI, functions like augmented intelligence. Now, all these parameters are very technical in nature, but they are very well documented in here. If you go to the EazyML.com and you go right in here in the configuration section in here, at the bottom of this page here, configuration. And here you will find a document which describes all of these parameters in their gory details, if you're interested in tweaking the behavior of augmented intelligence. Now, let's say you wanted to go a step beyond. You wanted to be able to program, not just the configurability aspect of this platform, but also you want to be able to program. Then you can go click on for developers, and in there, you'll come back to this API documentation, comprehensive set of APIs, like I showed earlier. And then there is a user guide, a quick start user guide, which will describe you how to get started with the APIs. And then either you can use APIs to build the models, derive the insights, or configure the behavior. All that is possible by means of APIs. And a lot of sample code segments are available on GitHub if you wanted to do that. In fact, these are the use cases which are deployed with largest of the banks in the United States and Canada to be able to use the power of alternate data in decision-making with these rules. Now, when you talk about integration with the enterprises, I said these are deployed use cases. So when you talk about the integration, in there, there is all the enterprises, they have some process in place today. So, but these APIs can be seamlessly integrated with the existing processes. You have processes for ETL. You may have data available or stored in data lakes spanning across all kinds of data stores, Amazon or Google's or the Azures of the world. And you may have an ETL process in place. Once you have compiled a data set like what I was showing earlier, a data set used like this using ETL, then you just have to use the APIs, the stitch together and build your own pipeline. And then all powers to you for taking the outcome from the EazyML pipeline and feeding it to your reporting and visualization tools and build rich reports. That's in a nutshell the augmented intelligence functionality, how it is being used in real life deployments with the banks and that was a use case from financial services sector. Now I'm going to hand over baton to Deepak to talk about the healthcare use case.
Thank you very much, Pranay. Deepak, it's all yours.
Okay. All right, guys. Hello, everyone. So I'm going to share a simple use case with you. You saw in detail with Pranay's demonstration the power of augmented intelligence in determining patterns automatically and comprehensively. Remember, no predictions. Usually people say machine learning synonymous with making predictions. Not really. That's straight-jacketing it in a very narrow sense. Here, the way Pranay showed, machine learning was used for mining insights from data. It did not make any predictions, just brought to you the secrets about your business processes hidden in the data. And as you saw, Pranay basically just kept clicking next, next, next. The machine made intelligent choices based on your data on its own. So for any regular analyst, it's fairly easy to use. Now I'm going to focus on a use case from healthcare, and a simple one at that, so that we can squeeze it in the time we got left. It has to do with systolic hypertension, your blood pressure. And you can see these are the regular predictors, the parameters that influence your systolic blood pressure, right? Hopefully you slept at night. Don't splurge on breakfast. Do hit the treadmill and be on it for how many minutes were you there. Take your medications. By the way, try not to be stressed out at work, so on and so forth. These other diseases can have influence as well, and this is the outcome. What is your systolic pressure at the end of the day after you spend the day doing those things? So this is data from a real patient. And so that patient goes to the cardiologist and says, hey, I have high, what should I do? And the cardiologist says, well, make sure you sleep well, all the best area practices, right? And eat well and exercise and take your medications and does all that and records readings, does that for 3 months, has 115 odd readings here, assimilates it. For about 4 months worth, the patient records all that, and then he goes back to the cardiologist and says, I still see high. I'm doing all that you suggested, and I still see high. So for instance, he says, hey, I slept well, and I was on the treadmill as well for 14 minutes, took my medications, and it's still high. The cardiologist says, well, you take 5 milligrams of amlodipine, time to bump up the dose to 7.5. Right? That's the typical prescription. Patient decides to take matter in their own hands and figure out the root cause. So where is the root cause? What is the pattern embedded here that says, here's why your systolics are still high even though you're following all the good practices? No worries. The EazyML platform's here. It's easy to use. Let's just dump this data set here on the EazyML platform. Voila. Lo and behold, you have the reasons, the patterns that you were looking for. It says it's high when your evening walk, you did not go for an evening walk. Yes, you are stressed out at work. And your minutes on the Stairmaster or treadmill were less than 18.5, about 20 minutes. Notice the importance of this insight from data. It is actually telling you that everyone's heart follows best area practices, but in addition to that, it's personalizing medicine for you, Mr. Individual Patient, because your heart's wired per your genetic disposition in a particular way that may behave differently from other people. And it's saying, in your case, you should be on the treadmill for 20 minutes or more for you to sweat, the heart to pump blood to extremities, and the good hormones to flow. Okay. Maybe that's it. It's not 5 to 7.5 milligrams of amlodipine. Maybe I just need to be on the treadmill some more. Personalized medicine. If that's true, that would be invaluable input to a patient to control their systolics. Let's see. Let's see if that is true, because we know that augmented intelligence is very confident. Remember, it's actionable. It's very confident that it's 9 out of 10, that this is why, per the data, your systolics are high. All right, good. So let's go and check out and see if we can find if the machine is equally confident, let's say over 50%, to where I can influence change in my behavior, be on the treadmill some more, and my systolics would go to being, the patient's systolics would go to being normal. It turns out that here's a case. Remember, now I just have normal here, not high. And with 50.59 confidence level, the pattern mind says, if you walk in the evening, you really can't control your work stress level. It's tough to do that. But if you go out for long evening walks and do run on your treadmill for 20 or more, you will have normal blood pressure for systolic. Amazing. You have prescriptive analytics for controlling your systolic, addressing the root cause, personalized to you, and not a generic bump up at the dosage from 5 to 7.5. That is the power of augmented intelligence.
So
amazing. Now I'm going to wrap it up with key takeaways.
Yes, and there are some questions also.
Okay, data is the future. I mean, everything is generating data. You can't get away from it. Why get away from it? It's actually there to help you. It's an asset. And one of the biggest things that you can do with it, since most of our lives in business and enterprise is lived through expert systems, rule-based systems, so tighten your expert systems through these insights, because the business is dynamic. The rules keep changing. Your gut feel and experience may be outdated. And once you do that, let's say you just have a couple of percentage points worth of increase in the performance in these business processes, just imagine the amount of difference it will make to the enterprise. I mean, it just boggles the mind of how powerful augmented intelligence can be by just tightening up your business processes, the rules that drive it. And people are spending money like crazy on AI. Don't hold back, because you finally have solutions that do not require platforms, that do not require a steep learning curve and are transparent. So don't hold back. Jump on the bandwagon sooner than later when you're trying to play catch up. And in this case, you will find that we've been EazyML is very innovative, and a lot of large global tech behemoths are our partners, as also Gartner, who's increasingly our fan. And it's being filed in financials and healthcare. Thank you. We'll switch to the questions in the remaining minute.
Yeah, so thank you, Deepak. We have one question that we get asked a lot, and thank you for that question. Eric asked, besides finance and healthcare, what other verticals can we use this in? Can you answer that question?
Sure. It's wherever your data takes you, with whatever outcome you're trying to study. This is not a biased platform with preconceived notions. It will mine that data for the outcome you're interested in. So whether it's aviation, retail, government, education, whatever sector, you have the data, augmented intelligence will give you the insights. Even here, You want to open or close branches in banks. You want to determine the reasons behind hospital readmissions. You have the data, the insights will follow. The specific actionable insights will follow.
Yes, so we are data agnostics. It is applicable to almost any industry. Thank you for that question. The second question comes from Aryarup. What is the mathematical statistical basis used for the score?
That's the patent pending stuff. There are 4 P's at the highest level: purity, proportion, population, and perception, which basically means it's a complex function of these 4 entities, which basically means that how accurate are your insights or reasons for transparency. You know, like when I said, plenty of metrics to define accuracy of prediction, but there isn't a single metric that says how accurate are the reasons behind a prediction or how accurate are the reasons in the insights. The 4 Ps.
Okay, the next question is from Divyesh. What is the technique to improve the confidence level? Have a much larger data set of data that remove outliers.
That's the population piece, Divyesh, good question. That's the population piece. The third P is how many records, but watch out. Wish it were that simple. If you add more records and it turns out that it causes divergence rather than convergence in data, in other words, you added a bunch of records. Earlier, this was the scope of the domain, and now you added a bunch of records that are of this type. It has actually caused divergence. Then adding more records will decrease confidence score. But in general, you're right. Confidence score should go up as the population metrics goes up.
All right. One more question. Deepak Sharma asks, how much augmented intelligence option is different from predictive option to choose one over the other?
Very different. Good point, Deepak. Imagine if you just had access to predictions or predictive analytics. You would, to get to these insights, you would end up playing what-if games till the cows come home. Okay, I didn't still go from high to normal systolics. Well, you know what? Let me say I am on treadmill instead of 17 minutes. Does that help? Darn, it's still high. Let me try evening walk equal to yes. Does that help? Now it becomes okay, but still not normal for my systolic. What should I vary? It's a nightmare. Versus, you got specific rules here that tell you this is where you are, these are the parameters, and if you need to go to that particular risk category, then those are the values of those parameters. That's what you'd have to affect the change. Specific, to the point. With petabytes of data that you're mining, you cannot play what-if games. Those will consume your time, you'll be pulling your hair out. Augmented intelligence is the answer. It does not, I'll repeat, make predictions. It's about mining insights from data, not making predictions. That's predictive analytics, the traditional ML definition.
All right. Well, thank you so much. I know we are 4 minutes over time. We sincerely appreciate the participation. I'm going to enter my email there. If you have any more questions, please feel free to reach out to us. We'd love to hear from you. And thank you again. Any more questions, feel free to email us. We can hang out a couple of more minutes. If anybody has any more questions, we'll be happy to answer.
I think they had enough of us, Nita. All right. I'll stop sharing. Thanks, guys.
Once again, thank you very much for attending. Bye-bye. Until next time. Bye.
Bye.